Hi everyone, welcome to our SAP Tech Talks webinar. Before we begin, a couple of words about the event itself. The webinar will be recorded and then posted on our YouTube channel. You can ask all the questions in the Q&A field. Our speaker today is Oleksandr Ardashov, and the topic is Unlocking Efficiency with SAP BTP Kyma. Oleksandr, you have our attention.
Hi, hello everyone. Thank you for joining this awesome session. Thank you for being interested in the capabilities of SAP BTP platform, of the SAP Kyma environment. And today, basically, we will talk a bit of the SAP BTP Kyma platform. A few words about the speaker. So my name is Oleksandr, and I work with SAP for more than 15 years. I basically started from SAP NetWeaver portal as a developer, and now I am focusing on SAP BTP platform and all the things related to cloud solutions, services provided by SAP, and applications are hosted and developed with help of the SAP BTP platform. And our agenda today is, let me start from the very end. Basically, as we know, there are some environments are available on SAP BTP platform, and there is always a question where to use, how to use, and what to use. And basically today we will try to answer the question what to use and where to use. And before we will talk a bit about environments available on SAP BTP platform. And before, basically we start from BTP platform itself and what Kyma is. So today our agenda is like this. And let's start from the Kyma building blocks. And before we come to Kyma environment, basically I would like to highlight and remind one more time what BTP platform is. So basically, BTP platform is a platform managed by SAP, and it consists from several building blocks. And usually we start from account definitions. And SAP BTP platform has next setup. It starts from the global account. So basically, a global account represents relationship between subscribers, between clients and SAP. There we can define what kind of services are available to the users and to the clients. There we can see how those services are consumed. And basically that is our predefined working space in the BTP platform. Then definitely we want to somehow split the availability of the resources across different solutions, across different departments, and that part with that sub-account definitions helps us. So we can identify different sub-accounts and assign those sub-accounts to particular group of users and particular group of developers, and they will reuse or they will grant it to reuse some portion or particular resources, and with that we kind of split responsibility and split visibility of the solutions among the organization. And as BTP platform is a cloud platform, so of course it is available around the world, and it is split based on the regions, based on the data centers and regions where those data centers are available. Then let's assume that we have some applications or some solutions available to us. We define that those solutions will be assigned or might be reused some departments or by some project or group of people. And what those group of people can do, they can make a subscription. So one thing is to have an option to use solution. Another thing is to create a real solution and use it. And with that, subscriptions help us. So just creating, subscribing on some services, on some applications, we make the application itself available to us. And of course, it's not only about the applications. Sometimes we need system-to-system communication to the solution, or we need to design and develop our own solutions. And quite often we can reuse services which are developed and provided by SAP. And it means that we can define or we can subscribe on particular services, and those services can be leveraged by our own custom development solution. Like example, user identification services, login services, so those kind of services are available to us by SAP. And before I was talking mostly about how to reuse subscription services or applications or solutions provided by SAP or by partners. But also I mentioned that we have an option to develop our own custom solution. But one thing is to develop it. Another thing is to have environment where those custom development solution may be run. And for that, SAP BTP platform has 3 environments available to the custom development. It is ABAP environment, Kyma environment, and Cloud Foundry environment. So today we will focus more on Kyma environment because, not because, but I assume that most of us or many of people who have heard about SAP BTP platform, they already know and they already use Cloud Foundry environment. But today our topic is Kyma environment, and of course we cannot compare those 2 environments between each other. So basically, what is Kyma? Kyma is an open source project. It was launched 2017, and yeah, one more time, it is open source project licensed by Apache License, and SAP is a main contributor to this open source project. Kyma powered by Kubernetes, so Kubernetes is the main pillar of the Kyma itself, and basically combination of the Kubernetes and some built-in tools and open source projects which are available in Kyma as a module. That is basically a definition of the Kyma. One very important feature of Kyma is that everything what is added on top of the Kubernetes platform itself, or what is available in Kyma, so it is available with the custom resource definition, and which is CRD. And basically, that is one of the best feature of Kyma platform or platforms like Kyma, because there we don't need to manage different open source project with different tools, with different CLIs, and with different interfaces. So I would say I really like this representation of Kyma, and that is the best way how Kyma can be explained. So we can represented as Lego building blocks. And as a baseline, here, as I already mentioned, we have Kubernetes cluster. And on top of Kubernetes cluster, we have different modules are available. Basically, those different modules do not underestimate those modules by module word, because some of those modules are bigger than Kyma itself. So we have here quite huge open source project Istio, which is responsible which is responsible for the communication between nodes in the Kubernetes and outside the Kubernetes. NAT, OpenTelemetry, other microservices, and on top you can see SAP BTP module. And yeah, basically all those modules, not all of them, but most important, about most important modules, we'll talk shortly. So that is the best view how I would say Kyma can be described. So before we start Kyma, let me remind you a bit Kubernetes itself. So Kubernetes is orchestrator, orchestrator of the nodes. And basically it starts, and all Kubernetes clusters starts from control panel, which is master node. And this master node basically manages all underlying nodes. So we can define that we want to have different set of nodes in our cluster, but we always have one central plane, one master node, which is responsible to track what happens with the worker nodes, which is responsible to roll out those nodes, and which is responsible to restore those nodes in case of failure. And one of the key component, it is Kube API server. And with this server, we can basically communicate with the all Kubernetes cluster and with our nodes. And basically, that is kubectl with one of the most used CLI to manage Kubernetes cluster itself. I already mentioned working nodes, so it is node 1, node 2, node 3, depends on how what kind of configuration of the Kubernetes cluster was requested. And here the main component is pods. Basically, pods, it's the smallest runtime deployable unit to Kubernetes, and it is a wrapper for all the containers. Of course, here we have different services up and running, which can help to have our pods healthy and also up and running. That is how shortly Kubernetes cluster looks like. So now come back to Kyma runtime. So don't be scared, because picture is quite overloaded by different definitions, but here we need to remember that we have Kubernetes cluster as a baseline, and basically how the provisioning of this cluster starts. So we have BTP cockpit, and in the BTP cockpit, it is what is required from the admin user or from the user is to provision the Kyma runtime. So provision to control this process, we have Kyma control plane. Kyma control plane can start provisioning with the Gardener project, leveraging Gardener project, which is another one open source product. And it starts, or it makes available Kubernetes cluster itself and activate some modules by default. I already mentioned that we have SAP BTP service or SAP BTP service operation module or module add-on, and that is basically our glue between Kyma environment and BTP platform itself. Because one more time, we have cluster, which is something independent things. It's basically up and running on hyperscaler, which is a cloud platform, which is Google Cloud Platform, Amazon Web Services, or Azure environment. So it's completely independent thing, but still we need to have to leverage all features and all capabilities from SAP provided by SAP or partner services. We need some kind of the glue between platform itself and between Kyma environment and platform itself. So with that, we have BTP service operation module activated by default, and it helps us to identify, to set up the relationship and to reuse services available on the BTP platform. Another thing is API gateway. So basically, Kubernetes is a cluster, and this cluster has pods or some runtime setup, which is completely isolated from the global world. So basically, by default, users and anybody not able to access the environment, and here we need API gateway module to set up the rules, how users can communicate, what would be the URL, what would be the API rules, what exactly they can do, what kind of resources will be available from the outside, and what kind of resources should stay hidden, and so on. So this module is activated by default as well, and with help of this module, we have this opportunity to communicate with the global world. I already mentioned that we have Istio. Istio is part of the service mesh group modules, and Istio basically plays quite a huge role in Kyma because it helps us to set up communication between pods, between nodes and pods, and it helps us to get telemetry. It helps us to implement service mesh as well. So this module is also activated by default. Serverless features. So comparing to Cloud Foundry, basically, Kyma environment is able to provide an opportunity to build not only microservices, but also serverless features. So, for example, it is easy to set up a function to make this function available from the outside, and any solution or even users may consume those functions like the services, but there is no dedicated resources defined for this function. So it is shared resources used. Okay, so I hope I did some introduction of the Kubernetes platform and Kyma environment, and you can see, who is familiar with the Cloud Foundry environment, you can see that it is a bit more complex than Cloud Foundry environment, but there is also quite often question how the development process look like in Kyma environment and comparing with the Cloud Foundry environment. Let me introduce small solution which we have designed and made up and running. So this solution consists from, of course, this solution is deployed and BTP platform is used, but this solution leverage Kyma environment capabilities. And there, basically, we designed and defined the services which is responsible for the incidents, and the name of the service is incident management. Here from Kyma environment, you can see that we can communicate with HANA Cloud database, and HANA Cloud database is not part of the Kyma environment. So it means that we have a definition and we have set up how to leverage resources provided by SAP, which is HIMA Cloud DB, and we can leverage those resources from Kyma environment. For the simulation purpose and basically to build interesting scenario, we defined mock service as for HANA mock service, and this mock service basically runs on Cloud Foundry environment. So you can see that in one solution we can combine different environments, different SAP services, different resources, and all of them are available on SAP BTP platform. So here we have mock server, which simulates S/4HANA, and it is up and running on Cloud Foundry. In real production scenario, of course, it will be the real S/4HANA, and most probably it will be on-premise solution or private cloud or even cloud, public cloud S/4HANA. Doesn't matter, but that is also an option to communicate with those kind of backend systems. As Launchpad, as a UI part, we have small application UI defined for this solution, and this UI is organized with help of the SAP built work zone service. So this is how the solution looks like. And let me show you the small demo of the application itself. Yeah, so as you can see that we start working from in the SAP work zone service, and SAP work zone service basically legacy name is Launchpad, and sometimes even in the path to the service we can see this Launchpad, but basically a standard edition of the service. It's kind of UI where we can see a set of tiles. That set of tiles can be organized in groups, and of course some kind of the role model can be applied on top. So we can show some tiles to the user, depends on the roles assigned to the user, or we can hide them. Here we have quite simple application, so it is incident management system, and now everything works, and this service works with help on Kyma environment. Basically, we have service which communicates. The service communicates with HANA-DB, and it gets data from HANA-DB and shows to the user. But service which handles all the requests up and running on Kyma environment. So here we can add, for example, a new incident, and one important thing is customer. And we know well where we have customers are created and available. Of course, it is our backend system, and basically this data now gets from this mock service, which is up and running on Cloud Foundry. In a production system, it will be a real backend system. So now we consume data from our ERP system. We can provide some information about incident itself, types of messages, and store it. The customer was defined as this customer. New record is created, and that is the simulation how we basically build and how we combine different runtimes. Yeah, so that was about the solution itself. And let me remind you one more time what we saw in the past. So I started from BTP platform. Sorry, it was too far away. Started from BTP platform, and I started from the global account. So basically, this is the global account. Here, how this global account can be organized with the subfolders, with the sub accounts. This is the trial environment. I have only one sub account. And when I come to the sub accounts, sorry, here. First of all, yeah, we have two environments. One environment is Cloud Foundry, another one environment is Kyma environment. Both two environments are activated. The subscriptions. I have subscribed on HANA Cloud database. I have subscribed on Business Application Studio. This is the development tool. And I have subscribed on the application, which is Build Work Zone. So this application basically helps us to build the Launchpad and organize how the Launchpad looks like. So these applications are ready to use applications, and it's just enough to create a new subscription. Now, moving forward to the services. So I would like to highlight the runtime environments. First of all, what kind of runtime environments do we have? And as you can see, that we have SAP HANA Cloud, and it is available on other environments, which is quite interesting because usually we have, as I said, we had just only 3 runtime environments: ABAP, Cloud Foundry, and Kyma. So we have more environments, other environments also, like an environment. Then we have an instance of the database defined in Cloud Foundry. Then we have mock server destination, that is also SAP provided service to set up the destination, and rest of the services which are hosted on Kyma environment. Okay, so the development process, basically. The development process, here we have a comparison of the development process and development process for Cloud Foundry and for Kyma. We usually start from the instantiation of the project. So CDS init, we set up the project in our IDE development tool. Then once it is instantiated, we do development. Usually we do development for the database layer, for the persistence layer, for the service layer, and we define how our application will look like. Then we can run CDS watch to see how it looks like locally, to run it locally, and then we can build the project and make the artifact of what we have designed in the past. As you can see, all of the steps are common for Cloud Foundry and Kyma. Then now we see some difference. The difference basically we see in how we deploy. In case of Cloud Foundry, we just need to deploy the project. In case of Kyma, we need first of all build our tool. Sorry, not our tool, but we need to build containers. We need to add Helm, another one open source project, but basically with this tool, it helps us to organize how the containers Docker images will be from where it will be taken, how it will be deployed, and what is the relationships between those containers. And with Helm upgrade or Helm deploy, we can basically deploy to Kyma environment all our solutions. Yeah, so once we do deployment, here in the Kubernetes, from one hand, we basically can start defining what kind of pods will be used, how those pods should be set up, what exactly to deploy on each and every pod, and so on and so far. We have to do it manually. But Kubernetes has quite cool feature, which is workload types. And with these workload types, we can a bit simplify process. We can identify different types of the workload types, and Kubernetes cluster will set up for us and allocate for us the needed resources. So the first workload type is pod. With this workload type, we identify, or Kubernetes identifies, that pod should be created, what kind of containers should be up and running in there, and what kind of resources should be allocated for this. Another type is replica set. With replica set, we can define that we need service 1, 2, 3, 4, 5 up and running, and if we need to scale it, or if we need to mostly scale it, then we don't need to redefine the service 1, 2, 3 up and running and their relationship. So those services will be represented in the replica set, and we just can say, okay, just roll out me another set of what I had just deployed, and it will roll out the new replica of set of our application. Deployment, basically, deployment. This is the workload type, which say that we need to make a deployment of certain workload types, and in there it is defined what exactly needs to be rolled out. So basically, when we do a deployment on Kyma environment from our development tool, we create a deployment, and this deployment manages what was deployed and how we can proceed with that. Another workload type is stateful set, used for workload type when we need to set up database. And this, so the specific of the database is kind of, usually we need to have just one database, because otherwise we need to replicate data somehow between databases. And usually we need to have just one database, but we can have more than one or many instances, up and running instances, which will make or communicate with this database. And to identify that we need specific database in the specific place defined, and it should not be changed. So basically, this stateful set is used. Daemon set is closer to stateful set, but it is mostly used for our login agents and metric collectors. So when we want to collect logs and metrics, basically we expect that we will be targeted, or we will communicate with the specific node, with the specific part of the environment. And it doesn't mean, it does make sense to create something outside of our cluster or in different node. So we need to keep it closer, and we need to keep it. We need to have it up and running close to the things which we want to analyze, which we want to track. So for that, daemon sets are used. Jobs, basically, this workload type create a pod, create executable environment, but there is an expectation that just only once or certain times this job will be run, but rest of the time the job will be stopped. So there is no nothing will be created which is up and running and keeps up and running. And cron job, it's basically similar to the job schedulers, and the idea of this type is just to keep some jobs periodically up and running, periodically run. So this time I would like to show you how the basically cluster looks like. This is the Kyma cluster. Here, as you can see, we have modify modules tab, and some modules are already available and active and ready to be used, which is API Gateway, BTP, and Istio. And of course, I can add more here. All artifacts are organized with the namespace in the Kyma runtime. So basically, if we compare with the Cloud Foundry, in Cloud Foundry we have organizations. Here we have namespaces, and these are workload types which I just recently highlighted, and we can check that deployment. We have server management deployment type. Then interesting part is pod. We have certain jobs are defined and controlled by different workload types. So one of the job is HANA deployer, which basically deploys our data model. Another job is job which deploys the content. And if I move to the graph view, here we can see the relationships that we have first deployment, and this deployment is created when we deploy our project, and basically how those things are related to each other. As I already mentioned, here we consume some data from the BTP platform, and this consumption basically happens through secrets. So in these secrets, we have definition of what is the credentials to the services which are available on BTP platform. And one important thing is service management, but that is basically service management. That is our module which helps us to communicate with BTP platform. And to anybody who is familiar with the BTP platform development, we know that when we deploy our project, there are certain instances are created and bindings. So bindings helps us to resolve issue with the accessibility or with the interaction between modules. So here we basically see or have information of how we can communicate and what would be the credentials to communicate to those services. So basically, those mostly of those artifacts helps us to run service. One more time, service itself is our middleware, and here we can see that we have several containers, which are Kubernetes containers. Here we have service up and running, and Istio proxy, who helps us to communicate to other environments. That is how Kyma looks from inside. And moving forward to basically key takeaways. Okay, Cloud Foundry. When we talk about Cloud Foundry, we know that this is the runtime environment where we can identify some custom development, or where we can place custom developed solution, and usually those solutions are used to extend our existing SAP applications and basically to follow the clean core practice. So here we expect that it will be the development, which is quite simple, and it's kind of business extension to already available solution. Cloud Foundry is also open source project. It was driven by Bosch, and SAP also contributes a lot on the Cloud Foundry, and community develops the Cloud Foundry environment quite intensive or quite active. Cloud Foundry also supports BTP services, even though we kind of have an assumption that Cloud Foundry is something which isn't built. It is, again, a standalone environment, and we need to make friendship, set up friendship between Cloud Foundry and BTP platform. So, but basically when the Cloud Foundry is activated, then it's done by default with the BTP services. And it requires quite, from the beginning, it can run with quite small resources and consume quite small resources. So it means that if we need really a small solution, then we don't need to allocate lots of resources and basically pay to a cloud provider lots of money. From the other hand, Kyma. Basically, this is environment designed and built for cloud native applications. So here we really have everything which suits to cloud native paradigm, to cloud native let's say definitions. And here, as it is Kubernetes cluster, we kind of built real big solution. Kyma fully managed by Kyma and by SAP Kubernetes cluster on top of hyperscaler of your choice. So it could be Google Cloud Platform, GCP, it could be Amazon Web Services, it could be Azure. So any hyperscaler can be chosen to run Kyma and Kubernetes. Also supports BTP services. So one more time, as I mentioned, those environments are completely standalone environments, and we need somehow to allow them to communicate each other. And what I already mentioned, Kyma combines microservices and serverless functions. So Kyma is the only environment where microservices, where serverless functions can be designed. Microservices can be designed in Kyma and in Cloud Foundry. And not the pleasant things. So it's kind of, it requires lots of resources from the very beginning, and most of the resources from the start is already reserved by the infrastructure. So it means there is no sense to build small extensions. So, for example, if we want to extend a business partner by just new property, it doesn't make sense to start with Kyma. It makes sense to consider Cloud Foundry in this case. Key takeaway of the key takeaway. One more time, Cloud Foundry is more suitable for side-by-side lightweight scenarios. For example, when we need to extend business partner, where we need to extend some standard object of the SAP public, SAP S/4HANA public edition or SAP S/4HANA private edition. And if we follow clean core approach, then Cloud Foundry is most suitable option and solution for that, because it requires not big amount of the resources, and from the development process we saw that development process itself quite similar, but deployment process takes some extra effort in case of Kyma. And solutions like if we want to design application where we need to keep some temporary data before we want to submit this data to S/4HANA. If we want to design solution where we, one more time, where we extend some standard object by new attributes, by new columns, if we want to design pre-approval process for those kind of the scenarios, Cloud Foundry is more suitable. What about Kyma? So Kyma is suitable for heavy loaded scenarios. As we already mentioned, it is based on the Kubernetes cluster. Kubernetes cluster consumes a lot of resources from the very beginning, and there is no surprise that heavy loaded SAP solutions are extended with the Kyma environment. And as an example, we have SAP SuccessFactors, for example. SAP SuccessFactors may have different or may have quite complex logic to be implemented and to extend the standard, because the processes in the company are quite different, and of course it's not always possible to follow all guidelines or all business scenarios. Those business scenarios needs to be extended somewhere. It expects that a lot of users from the outside will use this solution, will use this extension, and I would not even consider it like an extension. I would consider it kind of a separate solution which extends the business functionality of the SuccessFactors. And the same basically with the customer experience, with the CX, the same approach. So I even don't remember if it's possible to extend it with the Cloud Foundry. By default, as I know, Kyma environment is used, and all the extensions are available only in the Kyma environment. So one more time, Kyma for heavy loaded scenarios where we need a lot of calculations, where we need lots of, where we expect heavy loaded scenarios, and where we expect lots of users who will use these solutions. Last but not least, so basically both environments support cloud application programming model, which we saw from the very beginning and in the middle. This framework basically helps to develop solution for both environments, for Cloud Foundry and for Kyma. And the kind of steps are in development process are the same. We define the same way the model, we define the same way the service layer, and basically that means, and the only difference is that we need to deploy and to build the solution a bit different way. But basically, it means that as we have the same source, the same approach how to build it, we can start from any environment. So we can start from Cloud Foundry, see that, okay, there is not enough power compute. We can easily switch to Kyma. And vice versa. We can start from Kyma, see that we are lacking experience in the organization with DevOps practice. We don't have people who knows well Kubernetes or who experience who struggle with some of the DevOps activities. We see that the solution is not loaded as it was expected heavily. So basically, we can switch back to Cloud Foundry environment, and that's also an option. And one thing that both two environments are supported by SAP service, by SAP CI/CD service. So we can set up pipelines, and those pipelines can help us build our code in Cloud Foundry or in Kyma. It means that even for developers, they can build solution, let's say environment agnostic. They can build solution for Cloud Foundry and for Kyma. That is basically it from my side. Thank you for your attention.
Oleksandr, thank you so much for this great input. It was wonderful. Now I suggest, going back to the Q&A part. And the question is, does Kyma enhance available Kubernetes service discovery methods?
I'm not sure, but basically everything what is available in Kubernetes will be available in Kyma, and the only thing that Kubernetes itself will be extended or enhanced by the modules which can be open source projects.
Thank you. Question number 2. What is the pricing model for Kyma?
To answer this question, I would suggest to visit discovery.sap.com, and there you can compare Kyma environments and Cloud Foundry environments. So all numbers are in there, and there you can see more in detail what's included and how it is calculated.
Thank you. And while you're generating new questions, we'd be happy to see you as part of our community on different social networks, and you can join us via the link in the chat. Question number 3. Which Kyma capabilities unavailable in SAP Cloud Foundry were used for this solution?
I would not say that it makes sense to compare the capabilities by the capabilities. I would say that there are completely two different environments, and they are quite similar. And if you go to sap.com or just type in the Google compare Kyma and Cloud Foundry, you will be surprised that there are not that much difference or hard to understand those differences. One of the main difference, I would say that Kyma supports serverless functions, and Cloud Foundry not supports and power compute. One more thing, of course, as it is Kubernetes cluster, it is much more easy to bring to the landscape and other containers. So, for example, it is easy to to bring Microsoft SQL database container and use, instead of HANA, Microsoft SQL. It is easy to bring any other containers to the cluster and leverage for kind of solution provided in those containers. But one more hint, when I mentioned that it is possible to replace one database by another database, do not forget that with that, you mostly won't be able to leverage cloud application programming model capabilities. But in this case, Cloud Foundry, I would say it's kind of monolith. It's still possible to kind of bring another services to Cloud Foundry, but much more. There will be much more problems with that than in Kyma.
Okay. Another one. When developing new applications, what are the main criteria for choosing Kyma over Cloud Foundry?
There is no criteria. So the suggestion, if you have this question, just start from Cloud Foundry, then consider Kyma if Cloud Foundry is not enough. That would be the simplest and the simplest answer. But when you build an extension for SuccessFactors and for CX, then first consider Kyma, then Cloud Foundry.
Pretty long one. Could you provide more details on the sidecar integration pattern using service mesh? Is Istio somehow restricted within SAP BTP Kyma, or can it be utilized with its full power and features?
I'm afraid that we will not have time to express all the limitations and all the capabilities right now. So it's kind of another one holy war. But kind of Istio is part of the Kubernetes cluster. Let's say it enhances the Kubernetes cluster. So I would not expect that there are a lot of limitations because of Kyma. So there should be the same approach and the same way, the same problems as we have with the Kubernetes cluster.
What are the persistence volume types in Kyma and the management options, snapshots, resizing, NFS sharing? What is the strategy for handling app failures after infrastructure upgrades?
Another one, holy war. So basically, snapshots, resizing, NFS sharing. So basically, Kyma and Kyma, which is hosted on SAP BTP, is fully managed by SAP. That means that in most cases, all the snapshot, all the NFS sharing are available with the additional modules like NATS, like any other modules. But as it is completely managed by SAP, so we do not have that much option for the disaster recovery or for the infrastructure upgrades or for the other things. And as you mentioned, that even Istio, it is highlighted and branded with SAP logo. So it means that when upgrade happens, then we can consider that it was fully tested and by SAP, and there should not be any infrastructure problems.
Okay, thank you. So let's check if we have any other questions left. Okay, it looks that you have answered all of them. So Oleksandr, thank you so much for this great presentation. I'm sure that everybody will have lots of takeaways. And I would like just to remind you that the recording will be posted on our YouTube channel, and it will be like the link to the recording will be sent in a separate email. Thank you very much for being here and for like sharing all these questions. It was wonderful. So have a good day.
Thank you.
Bye.